Here we're finding the inverse of this function, okay? And so the first thing we're going to do is we are going to switch our independent and dependent variables. So g of n is our output, or our dependent variable, and n is our input, or independent variable. And so I'm going to rewrite this as 4 n equals 4 over g of n minus 2 minus 1. Okay. And in previous examples, we turned this into a y and this was an x, but we can just switch the, the names for our dependent and independent variables. And now we want to solve again for this g of n. Okay. And so the first thing I'm going to do is I am going to add 1 to both sides. So add 1 plus 1 over here, so I get n plus 1 equals 4 over g of n minus 2. And now I'm going to multiply both sides. I want to get this out of the denominator, this g of n minus 2. So I'm going to multiply both sides by g of n minus 2. Multiply this side by g of n minus 2. And over here, I just end up with g of n minus 2 over g of n minus 2, which is 1. Okay, so I end up with 4 over here, and then g of n minus 2 times n plus 1. Okay, now I'm going to move this factor over here by dividing, okay, both sides by n plus 1. And so that gives me a 1 on this side, and so now I have g of n minus 2 equals 4 over n plus 1. I can add 2 to both sides. And so I end up with g of n is equal to 4 over n plus 1 plus 2. And now we designate the inverse by putting this negative 1. So this is really the inverse, okay? Inverse of g is what this notation stands for, okay? And this is what the inverse is of that function.